So we're finishing up section 5.1 by talking about another line segment called an angle bisector. We've already done it, but we're going to look at it in a triangle now and be able to apply it to the triangle proofs that we've been working on as well. So an angle bisector is a ray that divides an angle into two congruent angles. Alright, so you've done this before. If it bisects, if it's an angle bisector, then two congruent angles. And that should not be new, that's review, but we're using it in a different way today. So take a look at this triangle. We have ML here, this line through the middle is an angle bisector of angle NMP. Since it's a bisector of angle NMP, we know angle 1, let me get angle 1 in there first, angle 1 is congruent to angle 2. So angle 1 is 5x plus 8. And angle 2 is 8x minus 16. So just like we've done in the past, if you see an angle bisector, you notice that the two parts equal to each other. 5x plus 8 equals 8x minus 16. We go through and we solve. I'm going to move 5x over. I'm going to add 16 to both sides. I get x is 8. Now, just like we've done all year, reread the question. Find angle NMP, which is the entire thing. So I need to find one or both of these. So when I plug in 8, 5 times 8 is 40. That's 48. 8 times 8 is 64 minus 16 should also be 48 because we did set them equal. When I add 48 to 48, the measure of angle NMP is equal to 96 degrees. Example 2 here, you're going to see this picture throughout this entire unit. You're going to see this type of picture on a quiz and as well as on the test. So AD and BD are angle bisectors. So these two lines going to the middle are angle bisectors. So let's start by marking my congruent angles. We know if CAD, this small angle right here, is 21, and angle D is 115, I need to find this angle up here. So the way that I want to go about this is I want to use this bottom triangle first to find some information about the angles over by angle B. So if this is 21, let me switch colors so we know what's new. That's also 21. Then I know in this bottom triangle I have two things out of the three that I need. So I'm going to take 180 and I'm going to subtract 115 and I'm going to subtract 21. When I do that I get 44. What that tells me is that this angle over here is 44 because all three angles in a triangle have to add up to 180. And now because it's an angle bisector, if that's 44, so is this one. So what I want to do now is I want to find angle 1 by looking at the big triangle. So I'm going to just draw a quick sketch just so we can label it without the middle information. Here's B, here's C, here's angle 1, and here's A. I know angle A is the sum of those two. I know angle B is the sum of those two. And I know that all three of them have to add to 180. So if I take 180 minus 88 minus 42, let me write that down, I get 50. So the measure of angle 1 is equal to 50 degrees. Now we have AB is an altitude and an angle bisector of CAD. So we have a proof now. We're going to go ahead and write our given. Altitude and angle bisector. And the ultimate goal is to prove that AB is a median. So if we're trying to work backwards, a median means that these two are congruent. So my goal is to prove that those two are congruent. The way that I can prove those two are congruent is by using CP-CTC. So this is going to be a bit of a long proof, but we're going to get through it. So step 2. First, before we do that, let's number a couple angles. 1 and 2, and 3 and 4. That'll just make it a little bit easier when we're writing this. Step 2, let's use the fact that AB is an altitude. If you remember, altitude means these form right angles. So angle 3 and angle 4 are right angles. By definition of altitude. And because they're both right angles, I know that they're congruent to each other. Because all right angles are congruent. And so I've got those congruent. Let's go ahead and mark them. Let me erase these marks because we don't know that yet. I also know, since it's an angle bisector, angle 1 is congruent to angle 2. By definition of angle bisector. And let's go ahead and mark that. These triangles are touching. We've done so many of those proofs that when the triangles touch, we say that the middle side is congruent to itself, and that property is always going to be reflexive. Oops. Let's try rewriting that. Now I've got two triangles congruent because I have three things in each triangle, just like we've done all of chapter 4. So triangle CAB congruent to triangle DAB. And that is by angle side angle. Now we have, because triangles are congruent, I know that these two sides in green will be congruent. So step 7, CB is congruent to BD. And that's the 5-step acronyms. Corresponding parts of congruent triangles are congruent. And now because they're congruent, I know that this segment AB is splitting that in half, and it's going from the vertex, which means AB has to be a median. And the reason? Definition of median. So we used angle bisector, altitude, and median all in one proof, along with triangles congruent and CP/CTC. So we're really taking all of chapter 4 and all of chapter 5 and putting it all into one proof. If you take the time and you read through step by step, this is a manageable proof. All you're doing, using altitude definition, angle bisector definition, reflexive, and then triangles from chapter 4. And then we have a step just saying, going backwards, because they're congruent, now AB is a median.